So in this module, we're going to demystify automation, and not by throwing a bunch of tools at you, but by breaking automation down into what it really is. Something happens, work gets done, results go somewhere. That's it. And every single no-code automation tool, whether that's Power Automate, N8N, Zapier, whatever, is just a visual way to define that flow. Now, every workflow, without exception, is built from three things. You have triggers, you have actions, and you have outputs. And if you understand these three, you can reason about almost any automation, even before you touch a tool. So what is a trigger? Well, a trigger is what starts the workflow. It replaces you saying, okay, I guess I should run this now. And in Treasury, that's huge, because half the operational risk comes from delays, forgetfulness, or inconsistent timing. The most common trigger in Treasury is a schedule. Every business day at 8 a.m., every Friday afternoon, first business day of the month. Schedules are boring, and boring is good. Scheduled triggers are how you remove, did someone remember to run this, from your risk profile. File drop triggers can be an incredibly powerful tool in Treasury. This is when a bank file hits a folder. One of your ERP exports lands in a shared drive. That file arrival becomes the signal to start work. No one has to email. No one has to remember. The process starts itself. And this is how you eliminate timing gaps and manual handoffs between team members. You can also trigger workflows based on incoming emails, data values changing, balances crossing thresholds. These are certainly more advanced, but they're incredibly powerful. And this is where automation can become proactive instead of reactive. Now, automation does not require perfect data. What it requires is predictable data. Treasury teams often wait for perfect integration, but that delays value. No-code automation is designed to work with the reality you already have. Bank exports are one of the easiest places to start. You have CSV files, Excel files, APIs, even PDFs in some cases. If the file shows up consistently, automation can usually read it consistently. Folder-based intake is your friend here. ERP reports are another common source. Things like your scheduled cash reports, reconciliation exports, anything that can be saved to a file on a schedule can become an automation input. And trust me, you don't need deep ERP integration to get value. Excel and Google Sheets are not just outputs, they're also control layers. They can give you thresholds, entity rules, account mappings. These tables let business users control logic without having to change the entire automation itself. Now that's a huge governance win, it's a huge time savings, and it stabilizes your automations. Shared drives act like physical inboxes and outboxes. Files come in, files get processed, results get stored. This makes automation visible, auditable, and easy to explain. Now in this course, AI is your processing engine. It reads files, it interprets data, and it applies rules. And it produces structured outputs. Think of AI as a very fast junior analyst that never gets tired, is never late, and never asks for a coffee break. One of AI's biggest strengths is reading messy files. Have different bank formats, different column names, different layouts. AI can normalize that chaos into something consistent. And that's what a lot of automation tools before it, like robotic processes, couldn't handle. And that's a massive unlock for Treasury. Once the data is read, AI can summarize it. Total balances, day-over-day changes, large movements, concentrations and exposure. This replaces manual scanning with a structured review. And this is where AI becomes a force multiplier. Instead of just numbers, you get a narrative explanation, clear red flags, even suggested next steps. And this is what makes automation usable for leadership, not just Treasury analysts. Outputs are where automation either sticks or dies. If outputs don't fit how Treasury already works, they'll just be ignored. And here's the thing, simplicity beats cleverness every single time. Email is still one of the most effective outputs, as much as we'd like to not admit that. Daily liquidity summaries, exception alerts, distribution to leadership or teams. It's simple, reliable, and auditable. Teams and Slack messages are great for real-time awareness. Have a balance drop, a large unusual movement, a compliance exception. These can flag automatically, and this is how automation becomes part of daily operations, instead of a separate system running over there. Updated spreadsheets or Google Sheets are still incredibly valuable. Think about a master liquidity workbook, control dashboards, an audit-friendly archive. Automations can update these so humans don't become the manual integration layer. There's also shared drive reports. These can create a natural audit trail. What was run, when it was ran, what the output looked like. This supports controls and governance without any extra work, or again, without human integration. So let's start by designing the agent blueprint. Every strong agent starts with a blueprint. Think of this exactly like writing a job description. If you've ever onboarded a new analyst, you already know how to do this. If the role is vague, the output will be vague. If the rules are fuzzy, the agent will freestyle, and that's how hallucinations happen. So what is the agent blueprint? It's going to have your role, responsibilities, inputs, outputs, and guardrails. First, you need to define the agent's role. Your agent needs a single, clear job. Not, you help with finance stuff, but you are a finance analyst supporting monthly variance analysis for FP&A leadership. That role definition anchors everything the agent does. Second, we need to define responsibilities. Responsibilities answer the question, what is this agent allowed to do and what isn't it? Examples include identifying material variances, classifying drivers, drafting commentary, summarizing data. But notice what's missing. Posting journal entries, approving payments, or touching anything transactional. Agents assist, humans decide. Defining inputs. Agents are only as good as the inputs you give them. Be explicit. What file format? What structure? What columns matter? If the agent needs actuals versus budget, if it needs a mapping table, include it. Inputs can include things like Excel, CSV files, PDFs, PowerPoint decks, emails, tables, policy manuals, or specific instructions and SOPs you've written. Next, define the outputs. What does done look like? Agents don't know what you want unless you tell them. Do you want bullet points versus paragraphs? Do you want a summary versus painstaking detail? Do you want a table versus a narrative? Ambiguous output instructions lead to creative writing, not finance deliverables. Now your outputs, they can include commentary, tables, PowerPoint slides, summaries, really anything that you need, you just have to define it. And lastly, guardrails and non-negotiables. This is where finance agents become safe and you make sure you don't make any InfoSec people cry. Guardrails are the hard limits. Never invent numbers. Only use provided data. Cite your sources. Ask questions and stop and get a human if you're unsure. Think of guardrails kind of like internal controls. They're boring, but they're absolutely essential and most importantly, career saving. All right, so with our requirements done, now we can go ahead and move on to our agent blueprint. We'll bring our prompt over. Here's our prompt. Act as a skilled financial analyst. Using the agent requirements you helped me right above, create a blueprint for my AI agent. I will be building the agent at N8N. It needs to include the role, responsibilities, inputs, workflow, output, guardrails. Ask me any questions you need to give the best possible output. We could attach this if we were working in a new chat, but because we have it right above, if we stay in the same chat, we can just send it away and use the context, the memory, the retrieval augmented generation to pull all that in. All right, we'll send that away and we'll see what we get back. And it's already running. So here comes our AI agent blueprint. We have our role definition right at the top. Here come in our responsibilities. All right, there's our inputs. So our daily statement data, our historical data, how we're going to configure it. It's going to run at 7 a.m. daily. And then here's the workflow. So we're going to have a trigger. We're going to have to do a data ingestion. We're going to have to do a data ingestion. I'm going to normalize and prep it. We'll do some baseline calculations. We can also, tweak this as we go. We can give the AI feedback. It's just a really good framework for us to use. We'll have our rule evaluation. We'll assemble the daily summary object. Then we can generate an email narrative. Then we'll send the email, and then if we want to, we can do an operational logging that this ran. And then our outputs are going to be our daily liquidity summary email. And finally, our guardrails, so permission and action, accuracy and safety. So it's read-only. We're not going to be writing bank values. We're going to make sure it doesn't fabricate anything. We're not going to send multiple emails. It'll just be one. And then it's got some questions for us. So our bank data source. Bank data source will be CSVs in Drive. Look back window should be 90 days. Let's see, statistical deviation. Let's say simple z-score. Do I want the top 5 largest? Yes, that sounds good. All right, now it's going to tighten this into the node-by-node build sheet for us. So our blueprint's running through the new workflow. Not a ton of changes. It's just kind of customizing it for the few questions it asked us. Getting down to our baseline and our rules. There's our top transactions. Working through JSON. Pulling in our AI agent node to draft our emails. So again, not a ton of changes from the last one we gave us, which is good. It means it's kind of in a consistent structure. But this is allowing us to get some of those questions answered to make sure that we have exactly what we need. Outputs and guardrails, so we are just about done. Last couple of questions, we can jump over those for now. Let's go ahead and just grab our information and bring it over to Word to save it. All right, so there is our agent blueprint. I'm going to put our agent blueprint in Word, and we'll go ahead and save that. So we've got the requirements done. We've got the blueprint done. Our last one here is going to be our system prompt that will be next. We need to write effective system instructions. System instructions, are also known as the system prompt, is the agent's brain. The system instructions define the role of the agent, the tone with which they speak and respond, the rules that they follow, and their behavior. The system instruction is by far the single most important part of your agent. If you get this wrong, the agent's wrong. This is not a prompt you treat casually. This is the agent's operating manual. Everything you mapped in Module 3 now gets translated into instructions. Starting with finance tone and structure. Finance outputs need to be clear, concise, neutral, and decision-oriented. Tell the agent to avoid hype, avoid speculation. Use professional finance language. Otherwise, you're going to get Silicon Valley optimism instead of financial realities. It's critical that you use templates for reliability. Templates are how you use randomness. Instead of something vague like write commentary, you give headings, a bullet structure, ordering rules. Remember that structure creates consistency, which is what finance teams trust. Reliability patterns can include things like step-by-step reasoning, explicit rules of how to operate, even output templates to make sure you get exactly what you're looking for. And most importantly, fallback behavior when things don't go as planned. So let's look at a bad prompt versus a good prompt. Here's a bad prompt. Explain the variances. Well, what is the agent going to do with that? So here's a good one. Using the attached actual versus budget file, identify the top 5 material variances by absolute dollar amount. For each, classify the driver and draft 1 to 2 bullet points using neutral finance language. Only use numbers from the file. So we've got our requirements done. We've got our blueprint done. Our last piece before we start building is going to be our system prompt. And the system prompt is going to allow us to build the brains of the operation. Go ahead and paste our prompt in. Act as a skilled financial analyst using the agent blueprint you helped me create the master system prompt. I will be building the agent in N8N. It needs to include the role, tone, rules, behavior. Make sure it's reliable, including step-by-step reasoning, rules, templates, and fallback behavior. And then, as usual, ask me any questions you need to give the best possible output. We'll send that away and let ChatGPT do its magic. All right, and here comes our system prompt for our liquidity monitoring agent. We have our role there, our tone, Treasury professional, concise, plain English. Have our input contract. So here's what you're going to get through a JSON object, the daily payload. You've got the output. Oh, this is good. You must rely only on the input. If something else is missing, follow the fallback behavior. We have our non-negotiable rules for reliability. Here we're getting down into the behavior and the step-by-step reasoning process that we want the AI agent to follow. Again, the more we want to let it do its work, but the more structure we give it, the less decisions it has to make, and that's usually for the better. Getting through all of our steps, now we're getting down to the output templates. This will give us an exact output for our email. And again, we're not setting this up to be fancy for executives. This is literally an update for the team to look at. Template if it's all clear. Template if there's issues found. Here's our top 5 transactions. There's another template if there's data missing or a data error. And then we're defining our fallback behavior for what goes on if it's all clear, if there's an issue found, if something is missing. And then it's giving us a couple of questions, but I'd say overall, I am quite happy with this system prompt it gave us. Let's go ahead and copy the code out of here. So here I've got a system prompt file set up. We'll go ahead and paste that in, and there is our system prompt. So we are now ready. We've done our steps. We've mapped this. We've done the requirements, the blueprint, the system prompt, and now it's time for building. Now, at this point, you should be able to mentally picture a full automation. A trigger fires, data is pulled in, AI processes and applies rules, and lastly, outputs are delivered where they belong. And that's the entire architecture. No code, just structured thinking, and all based on the process map you've already worked through. Now, everything we've described so far needs something to connect the pieces, and that's where workflow builders come in. These are tools like Power Automate and N8N that are the glue of workflow automation. They don't make decisions. They move data, trigger steps, and connect systems together. Now, in this course, we'll be using N8N as our primary workflow builder. It's visual, it's beginner-friendly, it's flexible, it's free, and it's powerful enough for real Treasury environments. Now, you don't need to understand N8N yet. This module is about understanding what you're building. The tutorial is about how to build it. In the next section, you'll move from concepts to hands-on building. We're going to walk through an N8N tutorial where you're going to set up a real trigger, connect real files, add AI processing, and deliver a real output. That tutorial is separate from this core lesson, so you can pause, follow along, and build at your own pace. For now, though, the most important thing is this. You understand the building blocks of any Treasury automation. The tools are just a way to wire them together. So let's move on into the hands-on workflow tutorial.